All right, well, thanks everyone for coming out today. I'm John Blischak, and I'm talking about the Conda package manager and how, as an R user, you can utilize it to make your life easier. So I work remotely for the University of Chicago, and so I'm a part of a team that does interdisciplinary genetics research. So there's a lot of variety. So there's people with biology, statistics, CS backgrounds, and a mix of all three. And this means that they have different preferred tools, technologies, workflows. So we use a lot of R, a lot of Python, a lot of different bioinformatics tools. And also we work in lots of different environments. So people can use their personal laptops. We also have a HPC environment provided by the university. But this variety, while useful for research, generating ideas, makes it a real big headache and has a lot of challenges for software installation. So just from the symbol of installing software, multi-step instructions, when you find some new scientific software package and you want to evaluate whether it's going to be useful for you, it can take a long time, a whole afternoon, especially for stuff that's poorly documented. Many bioinformatics tools that we use are written in C, C++, Java, so if someone's on Windows or they're not as familiar with computing tools, this can really be a hindrance. The scientific Python stack, so like numpy, scipy, that sort of thing, if you want to install that just from their repositories, that's going to involve compilation. You need the right compilers, and you need to know a little bit what you're doing. In our HPC environment, we don't have any administrative privileges, so we can't install anything as root. We have to be able to do local installations easily. And if you use mainly R packages, we're a little spoiled because CRAN or CRAN does such a good job making it easy to install. They actually provide binary packages for Windows and Mac. So for the most part, as an R user, it's just going to work for you. But there are some edge cases. For example, if you ever look at a description page and you see the system requirements, those can sometimes be a little bit more difficult to install. And also, if you're running any of your code on the cloud or an HPC environment, you're going to probably be running on a Linux machine, which means you're going to have to compile from source. So you're going to have the right compilers installed. So preferably, when you find a new piece of software and you want to try it out or you want to install it, no matter where you are, it'd be a simple single command that you could just run it and not have to wait for the code to compile or deal with any of that sort of thing. And just getting installed on your machine is just the first part of the battle. Then you're likely to want to install it on other machines, right? So if you install it on your Windows desktop where you're running moderately, reasonably recent versions of Python and R, well, then you have a long-running job, so you need to run it on your HPC. Well, the system administrators never update that stuff, so you have like Python and R from 10 years ago. So your code's not going to run easily. And then your collaborator, maybe they are on Mac and they like to upgrade the second as possible, right? So they have the bleeding edge versions of Python and R. So ideally, there'd be a way for you to be able to share, to run your code in the HPC environment, but also have your collaborator be able to easily contribute to your code base without them having to change the version of Python or R installed on their machines. It's also important to be able to recreate environments, so especially in academia, the environment I'm in. You submit a paper, you forget about that project for 3 to 4 months, you get it back, they ask for a whole bunch of things to do, and you've moved on. You've upgraded R, you've upgraded all your packages, maybe you got a new computer. How the heck do you get back to that? And so it's terribly frustrating. It makes you feel like that. Hopefully there's some Good Place fans in the audience, because this is not the only GIF. So what we prefer is have some sort of plain text specification file that lists all the packages and the versions, and that can be used to recreate the environment. So if it's 3 months or even a year later, you return to a project that you want to try and adapt for other purposes, you should be able to do that. And from the other end, so not only installing software, but when we create software, we want to be able to distribute it to users. We want them to try it out. If they never try it out, they might not be convinced to use it. So we want to make it easy for them to install it and try out our software and see how great it is. And similarly, if the primary developer of that software, let's say they have a Mac, well, if they're getting all these questions, GitHub issues saying, how do I install it? And I have this crazy setup or whatever. It can be really hard, especially if you don't have regular access to all 3 operating systems. trying to figure out what the heck went wrong for this user can be very challenging. So preferably, you'd be able to provide simple installation instructions that would work for everybody, no matter what machine they have, and then just make you so you can focus on feature development and more interesting things than trying to figure out why it won't compile in some edge case operating system. Okay, lastly, this is something I like to do a lot, is I want to have the latest version. There's always bug fixes, new features to be able to do. And especially when you're starting a new project, I want the latest versions. But when you're juggling multiple projects, you're always scared that your old code, your current projects are going to break. And so how to get around that is not to always just install the latest version, because that's going to easily just mess up your computer. Preferably, you'd have a way to have different isolated environments on the same machine. So you can have sort of legacy versions for your current ongoing project, but then when you start up a new project, you can get the latest versions of everything and work on that, and switch back and forth as needed on the same computer. Okay, so how do we try and deal with this, and how can you? Well, the solution is to use a package and environment manager. And so I'm just going to define these terms, since that's what Conda is, just some background on what this is. So as a package manager, this is a piece of software that handles all the dependencies between software. So when you say, I want version X of software Y, it will handle all the dependencies, resolve all those, and install everything that needs to be done. Because you can imagine how quickly this would be tedious if you had to do this yourself. So let's say there's a cool new package you want to install. But it depends on package A, so you have to install that first. I would also B, and also C, a specific version of package C, and then recursively back the dependency graph. Well, maybe package A defines on package X and package Y, and package Z, and there's different requirements for the different versions. You want to be able to tell your package manager, I just want this cool new package, and let it handle all the rest. And so some examples that you may have seen to give you context for what Conda is doing. So there's lots of ones that are operating system specific. So if you're on Mac, you could use Homebrew or Mac ports. Then if different Linux distributions have their own, like apt and yum. And then Windows has one called Chocolatey. But if you invest in one of these operating system specific package managers, that's the only operating system that can be used on. You're not going to be able to run Homebrew stuff on Windows. You're locked in. And similarly, each language has their specific package managers. So when you install .packages, if that package from CRAN has a bunch of dependencies, it's going to handle all those for you. It's going to install them one by one. And similarly, other languages have their own. But of course, the problem here is when you're in an interdisciplinary team, you want to be able to do different languages and control how they all work together and have them in the same environment. You need something that's more flexible. And so that's where environment management comes in. So this is what I was saying. It's being able to have separate, isolated environments on your same machine, and you can easily switch back and forth between them. Just an illustration, you could have older versions of Python and R, and then the bleeding edge, and then none of these are going to affect your system level Python and R. So if you have if you have software on your computer that relies on the system installed Python, all this, or system installed R, much less likely, but all this different environments are not going to mess up any of that software because it's all isolated. So the example, so R has PackRat and various other ones, and other languages have their own, but again, they only manage the environments of packages in their ecosystem. And similarly, you can go farther and not just do the packages, but also do kind of start simulating the operating system itself, so using a virtual machine or a container. But in practice, I find these not as flexible as an environment manager to switch back and forth. It's also a lot harder to get Docker set up, especially on a Windows machine. So I hope to encourage you to try Conda. So it doesn't have these limitations. So it does package management and environment management, but it's cross-platform. So if you collaborate with someone on Windows and Mac, and it doesn't matter if you don't have that access to that sort of machine, they're going to be able to run these commands as well. It's language agnostic, and has a really good support for Python and R and compiled languages like C, C++, but in theory it can be used for anything. You can build and share your own Conda packages, and share your own Conda environments. So there's a lot of nomenclature and terminology. So what's the difference between Conda and Anaconda? So just trying to get this out of the way. So Conda is the software that does the package environment management. So Anaconda refers to the Conda management software plus like hundreds of scientific Python packages. So it's just one big bundle. People can just download it, install it. In practice, I don't normally do that. I normally install mini Conda that only involves Conda and Python because I don't use all those hundreds of Python packages. So that's just wasting space on my computer. Confusingly, Anaconda now also refers to the company that develops this open source software. They used to be called Continuum, and now they're called Anaconda. Okay, so a high-level overview of how this works. So user A on their machine, they write up a recipe for Conda. So that's going to describe the version of the software, where you download it, any dependencies, the license, and other metadata. And then on their local machine, they'll build a binary package. So they'll compile it themselves. So this could be, imagine, the author of the package that knows how to make sure the software works. If there's multiple steps, they know how to do it. Then they'll upload their package to Anaconda Cloud. So this is just it's provided by Anaconda. It's a place to store all these binary packages. And then any users can just download it via Conda installed on their machine, and they don't have to recompile it. It's a binary package. If they install it, it will just work. And similar with environments, if you have a project going and you have a Conda environment, you've been doing things and you want to be able to run the code on your HPC cluster, or you want to be able to have a collaborator run it, you can export the environment to a plain text file. So that describes all the software you have installed in either version. You can upload it to Anaconda Cloud or really anywhere. It's a flat text file. You could email it. And then your other collaborators or other users that want to recreate your work can recreate it on their machine. Okay, so one great thing about Conda that I like about it, so there's community channels, so that helps just about all the software you can imagine can be available via Conda, and if it's not there, there's a mechanism for you to be able to add it. So the general purpose community channel is Conda Forge, and that's where I'm the most involved in. I help maintain the R packages for Conda Forge. So if there's anything ever missing or broken, you could talk to me. Another popular community channel is BioConda, which I use a lot because we need the bioinformatics software it provides. And this is just a quick snippet from the recent BioConda paper, but it has over 3,000 packages. They've been downloaded over 6 million times. And on the right there, some comparisons to some other efforts to open source efforts to provide bioinformatics tools and R and Python and that sort of thing. And you can see for the on the bottom, for the relatively how little BioConda has been around, there's been a lot of adoption and a lot of support. And it's a testament to how convenient Conda makes it to install software. Okay, and so I put a lot of work into trying to make it Conda useful for our users. Like I said, I help maintain the R packages on Conda Forge. So Conda has different channels. And so as mentioned on the Anaconda Cloud, if you upload your own packages, that's going to be your own personal channel. And so if someone doesn't look in that channel, they'll never download your packages. So the lowercase r, that's the default provided by the Anaconda, the company. So they're a small group of people, and they try and pick up a couple of them, 100 of the most popular. So they're in like just under 400 range. So Conda Forge is over 1,000 now across all 3 operating systems. BioConda does not have that many, but that's because I realized at the last minute I forgot to put bioconductor packages on here. So BioConda actually does have a lot of R packages. They're just not from CRAN. They're from bioconductor. So those would bump all those numbers up. Another thing too, if you're considering using Conda Forge, it's not always the cutting edge because we have to create these binary packages for each version of R we choose to support. So we usually support the first patch after each minor release. So 3.4.1, 3.5.1. If there's a 3.6.1, that will be the next version supported.
You don't support any additional patch versions, just the first one?
Just the first one, yeah. And the idea is, like, we're not trying to replace CRAN, right, or be the most cutting edge. It's to be a stable, if you want a project to be able to recreate a lot of different environments. So. And since most packages can run, I mean, that stays pretty current. You get the latest versions of all the packages. It's just the only thing that's held back is the version of R. Okay, so a quick introduction to Conda itself. Okay, so installation, talking about how easy things are to install. Itself is quite easy to install. So you install an installation script, and then you run it. So on Linux or Mac, you just run it at the command line. On Windows, you double-click the executable file. On Linux and Mac, you have to close and reopen the terminal. And then you're just ready to go. And then because it's all local installations, it's really easy to uninstall. You just delete that local directory, and it's gone. So to install packages, it's conda install, name of software. So there's no multi-step directions. It's literally just one line. Our packages are prefixed with R dash, and this is to deal with name conflicts. You know, if there's the same name package named Python package as an R package, that'd be conflicts. So R dash, and then all lowercase will get you the CRAN package you want. And then if you have a specific channel you want to get it from, you just put -C. So this will install SAMtools, a bioinformatics tool from Bioconda. And normally you'd have to compile SAMtools, but since it's already a binary package, it just runs.
Are they compiled against different numeric libraries and things? I mean, high-performance numeric libraries, or how what do you get out of those? You know?
It depends. I think right now, so I know Conda Forge better. I'm pretty sure they only have like one main set of compilers that they're trying to support. I think in the past the problem is they're always trying to coordinate with what Anaconda's doing.
Yeah.
So I think right now there's been a big effort. So Anaconda just introduced a whole bunch of new compilers, and so Conda Forge is migrating to use those.
Not so
So
much the compilers. I was thinking more like the BOSS libraries. And
I see. Yeah. So no. So
numeric libraries.
So right now it's not. I think it's just BLOS. It's not super optimized in that sense.
It might even matter per channel or something, because we encourage, so we use Python at work, and we encourage anybody, like the contractor comes in on Windows, to use Anaconda, because the Python packages do that. Tend to ship with one of the, like Intel or,
Yeah, the OpenBLAS, which is Gito's BLAS, or OpenBLAS. I don't know if that's supported on Windows, but MKL would work on Windows,
Yeah.
for example, from Intel. But that's proprietary software, though.
but
MKL.
sometimes they get, so like Microsoft's are, the community R is open source, however, they
Yeah.
license with,
They got a special. I was involved with that actually. Yes.
Yeah. So you can get the Microsoft R Open from the Anaconda channel.
Oh, you can.
Yeah,
Oh.
but they have to be compiled for that. The support, like what I showed here, is for just the base R,
Okay.
right? If you wanted to use the Microsoft R Open, you're going to limit yourself to a lot smaller number of available CRAN
Yeah.
packages.
There's a trick there, like you can get the Microsoft R and then use their numeric libraries with regular R. It's like it's a good hack actually to get the MKL for free. Sorry.
That's okay. Okay, and so you can do R-related complex package management. So you can do an exact match. So if you say equals 2.2 for ggplot2, this is going to install 2.2.0. But you can also fuzzy match. So if you just use one equal sign, it's going to install the latest patch version. So it's going to install 2.2.1. You can also do ranges. So if you just want it greater than or equal to that, it's going to install the latest version. So which is, as of now, is 3.1.0.
Does it have every package version? Like other binaries for every package?
No, so Conda Forge is only like a few years old, so the coverage reflects just as things get added, right? So something that got added really early will be available for R 3.3.2 in whatever version it was.
We're not like systematically building binaries for all the versions.
No, we're not going backwards. It's really hard to go backwards with these compiler things, right? So we actually just recently dropped support for 3.4.1 because we couldn't get it to build with the new Anaconda compilers. Because normally we like to support two versions at a time. So we were supporting 3.4.1 and 3.5.1 until we couldn't build 3.4.1 anymore. But the idea will be to support 3.5.1 as long as possible.
So you don't even support R 3.4.1 anymore?
Not for new packages. I mean, there's tons of packages for
I see.
i3.4.1. Those are always going to still be available. So if you were using 2 years ago using
Right.
i3.4.1,
You're
with,
not gonna remove binaries that are.
exactly, they'll always be there. So it's a matter if you're starting a new project, then you would make different decisions. But you can always recreate the old environment with the binaries you were using at that time. Good questions.
Sorry I have one more. So.
Yeah, go ahead. Yeah. that
So
one.
if you're using an R package that it doesn't have a binary, then you just install that from source like you normally would. Like, do the users have like the compilers on their system to be able to install packages that need compilation or not?
I don't think so. Normally, I remember there was a recent discussion about this. I don't think the compilers are available if you've installed the Conda R. So you'd have to have those yourself.
So you basically can't install packages that need compilation
Trying to think if I.
unless there's a binary available.
Right. You risk. I mean, it might work, but yes, you risk the chance of being incompatible if it's a compiled.
Right.
But the nice thing too is you can always build things for your own channel too if there's something you want. Good questions. Okay, you can also search for packages. So what I'm doing here is searching for the bioinformatics software verify BAM ID from the Bioconda channel. But it's also more convenient if you want the interactive experience, you can just go to anaconda.org and search it, and it'll show you all the options from all the different channels. Because the one in the command line only searches for channels that you've selected, that you've chosen to search for, whereas on Anaconda Cloud it will tell you what anyone has uploaded. Okay, so it's important to configure your package channels correctly because it has a priority, right? So if you add bioconda and then add Conda Forge and then check your channels here, so conda config get channels, just because it's a priority. So it's just going to look for the R package in Conda Forge. If it's not there, it'll look in bioconda, and then finally it'll look in defaults. Okay, creating a new environment, it's just one command. So you say conda create, you give it the name, so I just called it proj1, and then you can specify arbitrarily many packages, and you can either specify the versions or not. If you don't specify them, they're just going to give you the latest one that is available. And then you could have a different one, give it a different name, different versions, and then you can switch between them with source activate, the name of the project, and source deactivate. And these are not going to affect the R and Python on your system. So if you just want to experiment with Conda, you can install it, do your experiments, and then either deactivate it or just delete the whole thing, and it won't have affected your machine in any way. And so I was saying it'd be ideal to save it to a file. So if you export it, it will save it to that to a YAML file. And just to give you a sense of what's in there, so it's going to have the name you used, any channels, and the ordering that. Though actually the ordering is not respected, but all the channels you used, and then the exact dependencies that you had. And then you could get that file to your collaborator however you needed to, and then their machine, as long as they have Conda installed, they would do conda m create, and that will recreate that environment for them right there. This part's a little bit trickier cross-platform, but definitely within the same platform that it works really well. And that's just because it's not impossible. Not all packages are available, for example, for Windows, because it's so different. It can be hard to get some for Windows. Okay, and so like I said, you can create your own. It's really flexible. So there's 3 steps. You have to write the Conda recipe, then you have to build the Conda package, so you're building it from source as the sort of the package author. Then you'd upload it to Anaconda Cloud, and then anyone else, say, you wanted to share it with. So let's say you had an R package that you didn't want to submit to CRAN, but it was useful for your other team members. This would be a way to make it easily distributable. Okay, so what do you need? What's part of a recipe? So you need the meta.yaml file. This is where you say the metadata, like the version and where to download it from. And then the build files, those are where you specify all the steps. So these could be arbitrarily complex, but all that gets hidden from the end user and Conda user. Then you'd run conda build, and then Anaconda upload. Now that package is available. And if it's a public channel, anyone can download it by adding your channel. So there's a quick, recipes can be a little intimidating, but just to get a sense, so they give you, you have the name of the package. This is called request. It's from, this is a Python package, the version, and basically what this is doing is telling you the URL on PyPI where to download it. It is to specify requirements. So a build requirement is something needs at a time at build time, so like compilers. So here you see setup tools. That's a specific Python package for building other Python packages. Then you have your run dependencies. That's when the software is actually running after it's been installed. So for example, you see setup tools is no longer here because the package is already built. And you can see you can have arbitrarily complex package dependencies, greater than or equal to, less than or equal to avoid, for example, versions that had a bug in it. But you don't have to write it from scratch, especially if you're trying to create an R Python package. There's skeletons that basically just work. So if you want to do a Python package, you just conda skeleton pypy, and then a cran package, you do conda skeleton cran. And one nice things too, like I said, if you want to distribute your software, you don't want to put it on cran because it's too specific to your group. If you have a GitHub repo with an R package and you've had a tag on it, you've tagged it with Git, you can just put your URL to your GitHub repository. That will create a recipe for you. And this is just to show an example of all the stuff you can set if you get an account. So this is my account on Anaconda Cloud. I have all my packages I've installed. I don't have any notebooks, but you could share Jupyter notebooks, and then environments for past projects of published studies that are there that anyone could download and recreate the environment I had used to create the results. Okay, and if you are getting into Conda and there's a package you want that's not available, all you need is a GitHub account. And we try and make it super easy. If you download this helper script and tell it what R packages you want, it will format it to Conda Forge specifications. And so when you submit it, it should be able to easily pass all the tests and get created to Conda packages. Okay, so what's the catch? So I've been trying to sell you on this, but it's not magic. So there are some caveats anytime when you're installing software. So one is speed. So you're creating all these separate environments on your computer, right? Well, that can take a long time. So for example, installing SnakeMake, which is a Python package, and then ggplot2 and all its dependencies. Well, that's 95 packages if you start from scratch. So it has to figure out all the right versions to install, download all those binaries from the internet, and then unpack them. So that takes about 5.5 minutes. But it compares favorably, because like if you were to actually try and bootstrap this from the start, if you started up like a Ubuntu Docker container and did sudo and did apt-get update and apt-get install, that's also going to take quite some time. So that took 16.5 minutes. The storage can also add up. So Conda tries to be as smart as possible using hard links. So if you have the same version of Python in multiple environments, it doesn't install at the same time. But presumably if you're using different environments, it's because you want different versions of different packages. So that can start to add up a lot, to multiple gigabytes per environment. It's kind of an all or nothing thing. If you're using Conda, you have to commit. So if you've compiled your own packages locally and you've messed with the library paths for the compilers and that sort of thing, or if you have some sort of really custom library paths for either Python or R, that is going to mess with your Conda environment. So that's one thing that people have trouble with. It's hard to use Conda on the side. Like just to use Conda install one little package might not be worth it to you. You really get the most benefit by committing to it. But also can't do the impossible. So there's some package that is just too hard. For whatever reason, some dependency can't be built on that operating system. So if it just can't be done, Conda, there's no magic. It's just doing it. It's just running the build steps automatically to build the binary beforehand. If the build steps don't work, you won't be able to create the Conda package. Okay, summary. Don't worry, we're about to get back to the GIFs. So install software. So we wanted a single command. So with Conda, that is conda install name of the software, and it's done. That's all that yep, that's all you have to do, and then you can start trying it out. If you have to install it on other machines, either yourself or your collaborator, you export the file, send them the file, and then they can create it on their machine. If you get back reviews and you have to do a lot of work, and the project was 3 months ago, no big deal, especially if you still have the same computer. Source activate the name of the project the environment you're using, and you can get back to work. Distributing software, again, you don't have to write a lot of documentation. Tell your users Conda install name of your software, they can try it out, and it gets started right away. And lastly, if you want to try something out, this is something I do all the time. Just create a new environment, install the software, source activate, do all your tests, and then source deactivate. And you haven't hurt anything on your computer, nothing's broken. Yep. So like I said, I do a decent amount of work with Conda Forge. So if this is something you'd be interested in, if something these are problems that you have, and you want to be able to make sure that R packages or Python packages your team uses are well represented here. We're always looking for contributors, so either Conda Forge or bioconda. And with that, thanks for listening, and I'll happy to take any questions. One more questions.
So when you talk about not mixing well, one question: if you forget you're doing that and you just do install.packages or pip install or whatever, is that installing? So long as you're already in the environment, is that going to install to the same library path in the environment and be visible, or do you kind of now have two libraries set up, one that's R and one that's Conda?
So you're saying if you have the so the question is, if you have the Conda environment activated and you do install.packages, where's that package going to go?
Yeah.
Okay, so that's actually one of my big frustrations, is that if you have a user library, it goes to the user library. It doesn't go to your Conda library, which is a huge pain, because then then you're not guaranteed to be using the Conda version when you run library.
Yeah, and it's probably left around when the environment's deactivated.
And then it'll be left around with the yeah. So that is not.
But it's built with the Conda stuff though?
It would be built.
with
Probably
your
not. It would be
other
with
stuff?
your compiler. So the package would work fine afterwards. It's just then your Conda environment is incomplete as well. So yes, I wish that it would ignore user libraries, but I have not been able to get
Well,
enough traction.
You just change libpath, right? And you've got it.
You can, but because so for example on Ubuntu, it automatically in the installation it looks for R/x86, all that stuff.
Yeah.
So if it's ever there, it won't ever ignore it. If you don't have to. It's not from rlibs user yourself that it automatically always looks for that. So the way to fix it would be to have the r.environ file from the installation ignore that.
I see.
But I haven't.
And like the base R Conda package could set up like
Yeah, no,
a site
Yeah.
profile.
Yeah, exactly. That's what I've tried to gain traction for, but I have not been able
That
to
would fix that.
get people.
Yeah.
Because then the argument is that some people maybe want their rlibs users, maybe they want to do that. So that's what's hard, right? Like I think yes, you should. An environment should be an environment, and you should lock it down. But if users are used to running install packages and it just working, and going where they expect it to, so that's hard. So I have not been able to convince everyone. But yes, it should be a simple fix. And it works the same for Python as well. It has the same bug. The problem is that they're not as common. It's not as common to install to a user-specific one. They have they have lots of different places they can be installed, so it's not as big a problem for them. So, but yeah, it's a big headache because I have my collaborators. They have their Conda environment activated, but they've installed all this stuff in their user library, so I have no idea what they're actually running.
So you're saying as a Conda environment, like essentially a pip environment under the cover, so pip just installs to the same place anyways.
No, it doesn't. It doesn't install in the same place. It installs different places.
So
It could be, there's many different ways in Python, like virtual NVR, lots of different places.
So is it true that you can't use command binaries at all with Conda?
Currently, no. So they're thinking about trying to save themselves some effort.
Seems like
That's a question I had.
You
Like, why not
solve
just
two
fall
Yeah.
through to the Windows and the
OSs.
Mac?
Yeah, exactly.
Yeah, so that's been tossed around, but I don't have the expertise or the leadership to make that happen. So that's been considered. They've also thought about trying to overrun installed out packages, like override it, But since our studio already does that, that seems like that could be a big headache.
Well, yeah, I know just like on a couple of our packages, we've run into problems with people running Conda environments trying to install
So it's always
packages.
TensorFlow, it's always the problem.
Yeah.
Yeah, it's always.
So I don't, and my feeling in those cases, they should just not use Conda, but I mean, not honest, but obviously it definitely has benefits, but it seems like right now most of the users are in the Python, like Python community, and like our user base is fairly small right now. So I think a lot of like these edge cases aren't yet worked out. And I know like in Reticulate they're running into a bunch of problems with like support for Conda environments and stuff, so.
Every other day
Yeah.
somebody posts an issue.
So it would be nice, I think, to get these things like smoothed over.
Agreed.
And yeah, being able to support like cran binaries would be a huge step.
Yeah,
towards
that would,
Especially because it's like these are binaries already exist.
Yeah.
You have all like 13,000 cran packages. ready
yeah,
to go.
it would be ironic.
And Bioconductor has binaries too. So, like other than Linux.
Yeah,
they're pretty much-
ironically, Linux would be the worst. You'd
Yeah.
have like all the packages for Windows and Mac available, but not Linux.
Exactly.
Yeah. Yeah, you guys should do that. I don't know what would be involved. It's just switch which R you're using. Just use the one from CRAN, and then it would work.
Right, but everything has to be compiled, like, they're using the same compilers across the whole ecosystem, right? So you have to be careful about where you grab things from. So,
I see. But of course, if you just use the stuff from CRAN, you wouldn't have to compile anything. I mean, you wouldn't need a compiler, in other words, right? It's a compiler-free situation for R and all the packages.
right, but not on Linux, right?
No, this is just for the Windows and the Mac.
Yeah.
Setting.
Yeah. Well, I know also that the Anaconda team feels that the Mac binaries are not always reliable on CRAN. They prefer to build those themselves. I know that. I don't know how they feel about the Windows one, but they've had trouble with the Mac binaries that are on CRAN. For whatever reason, I don't know enough about
Oh,
it.
because they use this crazy like custom version of Clang to build the binaries. So.
Yeah, they might change soon, because that was because of the Fortran. There was some,
Yeah.
there were issues with Clang and Fortran forever, right? I mean, that's fixed now. I don't know if it's fixed, if Simon fixed it on.
Yeah, so that could something could be fixed on that end, and yeah. So, but yes, I agree. I feel like there's a lot of, especially for how people use Python and R together, that there's a lot of potential here.
I mean, it is a good point. Like, none of the good container systems work on Windows, so really, I mean, it's basically, I tried to use Docker on Windows once and I gave up. It was nightmarishly.
I've never attempted. I've considered trying to install it, but I've never attempted.
It's really the only option to support all those operating systems, I think. Right now, anyway, until they come up with some.
I wonder though, do wonder if that's gotten better.
Is it better now?
There was an announcement a couple months ago, and I didn't really track it because I don't use Windows for real anymore, but that, like, there's some sort of, like, essentially userland Linux install even now on Windows. Like, they have.
Yeah, there's like the.
Yeah, I played with that, but that doesn't.
Yeah, if that's set up, that's different though. Yeah.
Yeah, that's totally different, right? Like, I mean.
But I thought, I just made me wonder if they were putting in enough of this, like, are you that far away from there to real Docker?
Oh, yeah. Well, Docker, that's an interesting question.
I mean, you could install Docker in that Ubuntu environment, but
You can't.
you
I don't
can't.
think.
Right? I haven't tried, but
Yeah.
I don't.
I
Oh,
think there
wait.
was some problem with that.
Okay, I can
People have
see. I
tried
believe that. Yeah.
And I mean, there's a Docker specific to Windows that's different than that, right?
Right.
I mean, of course, R doesn't use. Even the stuff that Microsoft is doing now is forever. R has used MinGW, right? So there's always been MinGW, which gives you except for fork, it gives you pretty much the standard library of any Unix on Windows. That's been around for a decade. That's what R's always used to compile on Windows.
And that's what
Microsoft has
that's what
always-
Conda's using as well. That's
Yeah,
how it
it's
gets
a
all that stuff to run on Windows.
But maybe Docker does support that now. I don't know. If they did, then it might work. I don't know. I have to try it again. I tried it once. I couldn't get it to work. It was a while ago though. Questions?
All right. Thanks for listening. Thanks for the questions.